The next topic in section 3, numbers of zeros. So we have two theorems here, and these put together basically mean that whatever size degree a polynomial have. So if it has degree 4, that means it has basically four zeros. So we have the fundamental theorem of algebra that says every polynomial of degree 1 or more has at least one zero. And then the numbers of zeros theorem says that as long as we have a degree of any size, that's why it says degree n, of any size, then we have at most n distinct zeros. So what that means is if we have a degree of 4, that means they could all 4 be distinct, right? The zeros could be x equals 1, 2, 1/3, and say 1/4 or something like that. They could all be distinct, or I have opportunity that a couple of them could be the same, and then I could have 1/3 or 1/4 like that. So they don't have to be all distinct, right? At most, that means I can't go more than what my degree is. There could be just one. There could just be one distinct zero, and all of them could be the same. So they could all 3 be 1, or they could all 4 be 1. So there's one, but at least it has to be at least one, and then at most they could all 4 be distinct. When they are the same, so like for instance, when these two are the same, we would just say that, okay, x equals 1 is a 0 with multiplicity of 2, because it's repeated twice. This one would be x equals 1 is a 0 with multiplicity of 4. So that's when they have repeated zeros. And usually that happens when we have a graph. So 4 would look something like this. And so here it would touch the x-axis and come right back up. So here's a 0, here's a 0, and then we have 2 right here. There's actually 2 zeros right there, so it repeats itself. There's a multiplicity. Okay, so here is an example of using that, because since we know we have, if we have whatever degree it is, we know we have that many zeros. So we can kind of go in reverse. If we know what those zeros are, if I have 3 zeros, then I know it's a degree 3. So we're asked to write a function, so we're kind of going backwards. So we were asked to write a function of degree 3 that satisfies this condition. So here we have our 3 zeros, and then we have f of 1 equals 3. That means on this function I have a point 1, 3, and so we're going to use that at the end to solve for our a, our kind of lead coefficient. So we kind of use our factor theorem too. We go in reverse, right? So if these are zeros, that means the opposites are factors, right? So x plus 1 is a factor, x minus 2 is a factor, and x minus 4 is a factor. And then, so we're writing a function, so this is equal to f of x, or y, whatever you want to put, f of x. But the only difference is now we're going to use this point, okay? So we normally just multiply all these together, and then we get our polynomial. But we want a distinct polynomial that goes through this point. So in order to have that, we're going to have an a out here. All right, so we're going to multiply these together. So we're just going to multiply 2 of them first. So it doesn't matter which 2 first. So we'll multiply these 2 first. That's fine. So we get x squared minus x minus 2, and then we're going to distribute that whole thing 3 by 2 times x minus 4. We still have our a. Okay, so we'll distribute that, and then we'll figure out our a by using that point. Okay, so we FOIL that out. We get x cubed minus 5x squared plus 2x plus 8, and then we have our a. So there we have our a equals f of x. Now in order to find that a, I want to substitute in this 0.13 into our original up in there in blue. So I'm going to substitute my y, which is 3. So 3 equals a parenthesis, my x, which is 1 plus 1 times 1 minus 2, parenthesis. And you could have probably did this from the beginning too. And then 1 minus 4. So I'm going to simplify those. That's 2, that's negative 1, and that is negative 3. Okay, and then we can multiply those. So we get 3, we get 6. So a times 6 equals 3. So that'd be 1/2, right? So a is 1/2. And then so now we can go ahead and plug it in here. 1/2 x cubed minus 5x squared plus 2x plus 8. Now we can go ahead and distribute that 1/2, and we get our polynomial function 1/2 x cubed minus 5/2 x squared plus 1x plus 4. So there's a degree 3 polynomial going through that point. If I didn't have that point there, then I would just stop right here at this polynomial right there. But we're getting more specific because here's a point that I want to go through. Okay, so here's your homework, page 316 and number 49 and 53, so you can work on that, use that previous example. Go ahead and do that, and I'm about to start number 49 here. Alright, so here my zeros, negative 3, 1, and 4. So my factors would be x plus 3, x minus 1, and x minus 4. I got my a and f of x. So I could just plug in, if I wanted to start, I could just plug in this 0.230. So if I plug in that 0.230, my y would be 30, and my x is 2. So 2 plus 3 is 5, 2 minus 1 is 1, and 2 minus 4 is a negative 2. Okay, so we get negative 10. A times negative 10 equals 30, so a is negative 3. Okay, so we know what our a is. We can plug it in now. It doesn't matter. So we can FOIL this out. That's fine. X squared plus 2x minus 3. And now we're going to distribute that times x minus 4. And then we can times that by our a, negative 3. Distribute our a after we're done. So we FOIL that out. We get x cubed. We get negative 2 x squared. We get 4x, 8x, okay, 2x, and x is a 2x squared. 2x times 4 is negative 8x, and a negative 11x there, and then positive 12. Okay, and then we can distribute our 3, or negative 3, excuse me. So we get negative 3x cubed plus 6x squared plus 33x and a negative 36. So that is our f of x at that certain point, 230. Okay, here's another one. This time we have multiplicity of 3. So that means x plus 3 is a factor. X plus 3 is a factor. And then it's multiplicity of 3, so that means it's 3 times. There's 1, 2, and 3. We got our a out in front equals f of x. Go ahead and plug in our f of x, which is 36. Plug in our x, which is 3, so 3 plus 3 is 6. 3 plus 3 is 6. 3 plus 3 is 6, so it's 3 6s. Well, we know 2 6s is 36, right? So if we divide by 36 on both sides, we get 1 is equal to a times 6. So a is 1/6. So a is 1/6, so we know that. We can put it in right now, or we can just wait. It's fine. Oops, a little too far. Okay, So now we can FOIL this out. This one's x squared plus 6x plus 9, and then we're going to distribute that to x plus 3. So on that one, we get x cubed. We get a 3x squared plus a 6x squared is a 9x squared. We get a 18x and a 9x. That's a 27x, and then 3 times 9 is 27. So there's that polynomial. Now we can distribute our 1/6 here. So our function at that point, or at least goes through that point. 1/6 x cubed plus 3/2 x squared plus 9 9/2 9/2 yeah, 9/2 x plus 9/2. Okay, so that is it. So you can stop the video now. I'm gonna do another one, just in case. Okay, never mind, because that will come up later in a different subject. So on this section. So we're good for there. Good for now.